students, welcome back to my class. In the series of learning programming in C, in the previous video we have discussed about indirect recursion with a programming example. In today's video, we'll continue the same topic, that is types of recursion, and we are going to discuss about tail and non-tail recursion. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. If you like the video, please click on the like button and share the videos to all your friends. Tail recursion. The name itself tells you tail. It is the last part or the last portion of the animal, right? So in the same way, when I say it is the last portion with respect to a function, it is the final recursive statement or the last recursive statement. After that, there will not be any other statements. So if a function contains the recursive statement as the last statement, then it is called as tail recursion. So what the definition part of tail recursion says, a recursive function is said to be a tail recursive function if the recursive call is the last thing done by the function. So the recursive call, the recursive statement that what we write, if that is the last statement in the function, then this is called as tail recursion. And added to this, there is no need to keep record of the previous state. See, when I say when we have recursive function, all the statement will be put into the stack memory. So when we say we are putting the statements into the stack memory, the previous state or the previous data that what the recursive holds need not to be remembered or need not to be kept track. We need not keep record of the previous state. So let us understand what actually this tail recursion. Hope you have understood the definition. We have to understand with the terminology itself first of all. It's not simply you mug up the definition in the book or the definition that what we get in the Google or whatever it may be. We have to understand with the terminology itself. Tail means it is the last portion. So in a function, if the recursive call itself is the last statement, then it is tail recursion. If not, it is non-tail. We'll see that later. Okay. So let us understand this tail recursion in a better way with an example. So here we have a very simple example to understand the tail recursion. So we have the function declared as fun and taking one argument, main function, only one function call we have, nothing else. This is what the function definition part. So function int n, this is what the complete part. So let us see what happens. Let me write the iterations or what we can say, how the statements will be put into the memory, stack memory. So we have the function called function3. I am passing the actual value itself. If you want, you can just take the value from the console. So I just say fun of 3. Function 3 is put into the stack memory. So 3 is the actual argument that what I am passing. This is what the actual argument received by the formal argument n. So n is receiving the value 3. So we have totally how many snippets? 1, 2, 3, 4, 5. That is put into the memory of function, that is subfunction memory. So the subfunction is activated now. So all these statements will be put into the stack memory. Now I say the statement 1, 2, 3, 4 and 5. So I just check n equal to 0. N is 3. So this n is receiving 3. 3 equal to 0? No. Condition not satisfied. So a return statement will not be executed. I'll come to else part. In the else part we have two statements for execution. I need to print the value of n. So I need to print 3. So let me write the output here. So the first statement that what I am going to get is 3. Then I say I'll come to else part and then I'll print. This is 1, 2, 3, 4 and 5. Fourth statement, printing the value of n, that is 3. Then I say fifth statement, recursive call. I say see here. Look at this function actually. So recursive call is the last thing to do in this function. So I can call this as tail recursion. So when the recursive function or the recursive call is the last thing to do in the function, then it is a tail function. That is the tail, the last one. So when the recursive call is the last statement, then it is tail recursive function. So I am calling the function the simplest form n minus 1. So I am calling fun of 3 minus 1, that is 2. So I am calling function of 2. Again the control is back to the same function here, right? So now it is fun of 2, the first statement, 2, 3, 4 and 5. Is 2 equal to 0? No. Coming to the else part, then I need to print 2. Again a function call of fun of 2 minus 1, that is 1. Again back to the same function, again to the stack, again function activated, function 1, 1, 2, 3, 4 and 5. Is 1 equal to 0? No. Come to else part, then print that 1 value. So here I need to say 2, then I need to say 1. You can just have /t so that you can have proper tab space here. Then I say print 1, then again call function of that is 1 minus 1, it is 0. Again back to the same function, I am calling function of 0. Again all the statements, but here this time just look at, I am coming back here. What is the n value? It is 0. 0 equal to 0? 0 equal to 0? No. Here, 0 equal to 0, condition satisfied. So I need to execute this statement. I say return. Simply say return. I am not returning anything. I say simply return. Return to the place where this function was called. Function 0 was called. See, function previous state, it is not returning any value. So I am simply saying return. So the control will be back to this. Is there any statement remaining? No. Function 0. That is the last statement. The function ends. Again it returns back to the place where this function was called here. Again it returns back to the place where this function 2 was called here. Again it returns to the place where function 3 was called. So the control will be back to main. So it is not returning any value. So the control is simply returning back, but that becomes the last statement. This recursive statement will be the last thing to do in this function. So I'll simply say return. Return means, here I say return to the place where this function of 0 was called. It comes back here. Again this function of 0, that is done with that. So here when I say return to the place where this function was called, means function of 0 was called in the previous here. Return to the place where function of 0 was called. So here, that is the last statement, right? Again return, that's the last statement. Again return, that is the last statement, right? Again return means to the place where this actual function was called, the main function. This is tail recursion. Let us see with the non-tail recursion. See, the last thing to do will be with recursive function. Then it is called as tail recursion. So now let us see non-tail. Then you'll understand what actually this tail and non-tail is. So here we have the definition of non-tail recursion. So let us see what is non-tail recursion. A recursive function is said to be a non-tail recursive function if the recursive call is not the last thing done by the function. Non-tail means that will not be the last part. There will be something else to evaluate after recursive call also. After recursive function, there is something left out. So after returning back, there is something left to evaluate. So in the previous example that what we saw, there was nothing to evaluate. I simply return. So when we come back in the previous example that what we saw, when we come back in the recursive flow, there is nothing left to evaluate. That because that is the last statement. I'll simply return. But here in the non-tail, it says you have to evaluate after returning back. When you return back, there is something left to evaluate. So let us see that with an example here. So here what happens, the same function, just observe, I have interchanged these two statements. So function 3 I am calling, control will be to here. If this statement not executed, the return statement will not be executed. I'll come to else part, to statement for execution. Here I'll have the recursive call. When I'll have the recursive call directly, the control will be to the same function. And what type of function call it is recursive? It is direct or indirect? It is direct recursion, because the same function is calling the same function. Right, so it is direct recursion. In this direct recursion, it is what type of recursive function we have? We have non-tail, because recursive function is not the last thing to be done in this function. Recursive call is not the last thing to be done in this function, because you have one more statement left out. So when I call the same function, when I say return to the placements, it will come back here and then take the statement, the remaining statement. See, this is the recursive call. After recursive call, you have one more statement. So this is non-tail recursion. So let us see the tracing of this, like how it is going to return back and how this remaining statement gets executed after returning back. How this evaluation, or some evaluation will be there sometimes. Here it's the same statement. We may have some evaluation, right? So let us see how this is going to work. So we have the function declaration, main function. I am calling the function. So I am passing the actual argument. So received by the formal argument, that is n. N is receiving the value 3. So I am calling the function of 3. So I have how many statements? 1, 2, 3, 4, 5 as usual. So let me write the statements that is put into the stack memory. The first statement I am going to check is 3 equal to 0. No. I'll come to else part. Fourth statement, I'll say, look at here, that is a recursive call. So I just say fun of n minus 1, that is 3 minus 1, 2. Whereas this fifth statement, which is printf, is still pending. It is still pending. When I say function of 2, the control will be straight away to this function call. So function of 2 will be called. Okay, so here function of 2 will be called. Again, check all the statements. 2, 3, 4, 5. 2 equal to 0. No. Come to else part. Recursive call. Function of 2 minus 1, which is 1. Again, the control will be to the function, same function, where this printf is still pending. It is still pending. Okay, then I'll call function of 1. Again the statements. Now I'll say 1 equal to 0. Again condition not satisfied. Come to else part. Have a recursive call. Function of 1 minus 1, which is 0. Again this printf statement will not be executed. It is pending. See, let me write it here. This is pending statement, not executed. Pending. You can understand, this is pending. This statement is not yet executed. It is pending. Okay. Again function of 0. Again the same function call. So I say function of 0. The statements 0 equal to 0. Yes. Condition satisfied. I'll simply say written. So written means where it has to return. Return to the place where this function 0 was called. Function 0 was called here. Right. Function 0 was called here. Simply written. The control will be to this point. Then see, control will be to this point. Then this statement. The remaining statement. So I'll say printf. What to print? The value of n. So what is the value of n? It is 1. Print 1. So print 1. Again all the 5 statements done. Again return back to the place where this function 1 was called. So here when I say written, it will return to the place where function 0 was called. I'll come here. Previous. See, moving forward and moving backward. This we have learned in the previous programs and all. Okay. See here I say return to the place where function 0 was called. Function 0 it was called here. So here this is Non-tail because recursive function call is not the last thing to do. You have one more statement to do. So that one more statement I have to execute, then I have to wind up this function. So I'll print that value, 1 is printed. Then that is the last statement. So this function is winded up. It's done. This function is done. I'll return back to the place where this function was called. So here control will be to this place, again this. Printf that value of n. So it is 2. Again all the 5 statements done. Return to the place where this function 2 was called. Right. See, return all the 5 statements done. Function 2 was called in this place. Control will be to this place, and this remaining statement which is pending will be executed, which is print the n value, which is 3. All the 5 statements done. Again return to the place where this function 3 was called. Function 3 was called here in the main function. The main function ends here. I'll get the output 1, 2, 3. Okay, just observe the previous example that what we saw with tail recursion. I got the output as 1, 2, 3. Right now I got it as 3, 2, 1. Now the output is 1, 2, 3. See, this backward movement you should know and forward movement you should know. So when I say return, simply return to the place where this function was called. It is called here. I cannot simply go back to the previous backward function call because you have one more pending statement here, because it is non-tail recursion. See, after this function call you have one more statement. That statement has to be executed. Then I need to wind up this function. Then return will be to the function 1 here. Got it? Again this pending statement. Again return to function 2. Again this pending statement. Again return to function 3. It's here. Let me give you one more example for non-tail recursion so that you can still understand how I can identify that as a non-tail. It's not that you have the statement in the next line. You may have the statement on the same line also with some evaluation pending. Let us see that now. So here is one more example for non-tail recursion. See, when I say after recursive call, if you have one more statement, then it is non-tail. But look at this example. See, you have the declaration and I am calling the function the printf. You can do like this also. Call the function and whatever the answer I get here, you can simply return and print it. So here I should say it is computing something and returning. I need to change the return type as int. And here also I need to change it as int. Okay. And it is printing here itself. Some value will be written and I am printing that straight away. So 8 will be placed here. If 8 equal to 1, I will say return 0, or else look at here. Computation part is there. Return 1 plus, it is pending. 1 plus is pending. Function of n divided by 2. So it is 8 divided by 2, it is 4. A recursive call once again to the same function. Again it checks. Again pending. Again call. It goes on like this. So this is also an example for non-tail. So here when I say it is returning back at the end somewhere else n becomes 1. So it is going to return 0 means to this place 0 will be written and that will be computed. So some operations and evaluation is pending. When we go backward, if we are simply returning, then it is tail recursion. But we are returning with some pending evaluation or some execution of the statement which is pending, then it is non-tail. The previous example, a statement was pending, but here some evaluation is pending. I say 1 plus recursive call. So in the same statement, I have two operations to be done. One is recursive call and one some evaluation. So here the evaluation is pending. So this is non-tail recursion. So what is the output of this? You have to write it in the comment box. That is an assignment for today's video. So hope you have understood with the tail recursion and non-tail recursion. You have to work out with the tracing. You have to write down the tracing, then only you can understand. See you in the next video. Till then, take care. Bye-bye.